Now, we're going to say a little bit more about machine and so forth, but I want to divert just for a moment to the mathematical aspects of what's going on here. So, anybody here into math, into mathematician or computer science type, engineering types, maybe? No propellers today? Okay. Well, let me talk a little bit generically. So I mentioned that these humans were involved in creating these tables and these volumes. By the way, Babbage, being a kind of gentleman scholar, had a large library, and he had some 300 volumes of these things, and he actually used them and read them. And some of them he actually compiled himself, and it said that he proofread them 10 times each. So it turns out, in general, the way these things work, these were tables of what we call transcendental functions, such as logarithms like this table. These are kinds of mathematical functions that do not have what we call a closed form solution, so you can't calculate them directly. So what you can do is you can approximate them by certain functions that can be calculated, in particular polynomials. Maybe you ever used a French curve? You've done like hand drawing. So you know that let's say you have some data points and you want to synthesize a curve through those data points. Of course, now you do it on a PC. But several decades ago, what you would do is use this thing called a French curve, which is a kind of template. And you would have a desk full of these French curves of various kinds of designs. And you would take the French curve and physically lay it on top of the data points on a piece of paper. And with a pencil or pen, you would draw a line through the data points according to the physical aspect of the French curve. Well, it's analogous here. What we have are, in some sense, some data points that, again, cannot be calculated directly, but what we can do is we can approximate them by the mathematical equivalent of the French curve or an algebraic equation. So we have an example on the board here. So let's look on the left. We have a fairly simple second-order algebraic equation, x squared plus 1. So on the left, we have values of x, the arguments. Second to the left, we have column r, the result. That is the value of x squared plus 1 for the various values of x. Now, in the third column over, we have what's called the difference, or the successive difference in the values of r. So, for example, 2 minus 1 is 1, 5 minus 2 is 3, and so forth. Now take that one step further, take the difference of those differences. We have the rightmost column, or the diff2, difference 2 column. So 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2, and wait a minute, they're all 2. Well, why is that? Well, it turns out for an nth order algebraic equation, the nth difference will be a constant. And similarly, so in the third order example, for a third order algebraic equation, the third difference is constant, and so forth. This machine and the algorithm that the human computers utilize takes advantage of that constant difference. And how does it do that? Well, we can work backwards. So having calculated a few entries, we know now that eventually the nth difference will be constant. In this case, difference 2 is 2. We can populate the difference 1 column, sort of working backwards, and just increment by constant 2. And we can go the third step, and we can populate the r, the result column, so we can calculate results indefinitely by adding the difference once that we calculate. So what does the machine do? Well, it does just that, except it does it automatically.